Here at the College of Engineering at Oregon State University, our faculty and students research things across a number of engineering disciplines, at least 20 of them the last time I counted. For the most part, the areas they work in are pretty self-explanatory. Electrical engineers work with electrical systems, chemical engineers work with chemicals, roboticists work with robots. You get the picture. Today, we're going to talk about one discipline that's often misunderstood: industrial engineering. Right about now, you may be asking, what is industrial engineering? Well, let's ask some people who know. From the College of Engineering at Oregon State University, this is Engineering Out Loud.
See, I love this question because I get asked a lot, what do I do and what is industrial engineering? And typically what I say is that industrial engineering is an engineering of processes, but it's not just the process in itself. It's the manpower behind the processes. It's the facility layout. How do you optimize where you're traveling to get parts? And so that's why I love industrial engineering, is that you really become a jack of all trades in different fields.
We can work in any industry. It can be government, it can be healthcare, it can be manufacturing, it can be service industry, because all of them have processes, right? There's a process on how to build customers. There's a process on how to ship our products or how to do better service, right? Even airlines, how is it that we determine what is the best way to load or unload an airplane? That's a process, and that's something that an industrial engineer can do.
You just heard from Sage Kittleman, a PhD candidate, and Javier Calvo Amadillo, an assistant professor of industrial engineering. Both of them work in the Change and Reliable Systems Engineering and Management Research Group, or CARSEM, which Javier directs. The CARSEM group focuses on understanding how to design and manage systemic changes in large organizations or companies. They're especially interested in how the people affected by those changes understand and react to them.
The problem is not only how well designed the process is how we help people embrace the process and be consistent at using that process. That is a very difficult problem to solve. Because, well, people are people, right? We don't like change, first of all, right? Our brains are wired that way. So how do we help people embrace new ways of doing things? Or even if they're doing something a certain way, how do we get them to do it consistently well without them getting bored? Just doing the same thing 8 hours a day, that is not sustainable because the brain gets tired of that. You get bored and mistakes happen. So how do you change things? How do you design process that will keep people engaged and like what they're doing?
For the past 3 years, the group has been working with an aerospace giant you may have heard of.
With Boeing, the problem we're helping them to solve is how to help their people to embrace a new way, a new culture, manufacturing culture.
Boeing Portland manufactures components for commercial airplanes like the 737 and 777. Since the 1990s, Boeing Portland has implemented a number of projects aimed at improving the quality, delivery time, and overall performance of the facility's operation. Each of these initiatives have built on each other. Most recently, leadership of the organization has come to understand the importance of changing the site culture to be a leader in the industry.
Because they're moving from a traditional enterprise resource planning push manufacturing system to level pool manufacturing system. What that means is that, that requires many changes to be implemented.
Boeing Portland's program for doing this is called Boeing Production System, or BPS. BPS is focused around what Boeing calls one system, one voice. This is the idea that even though the company is comprised of multiple business units, each with multiple teams made up of individuals, the message coming from all levels of management should be consistent. Throughout the company, they share a common language, utilize the same performance goals, and use data to move initiatives forward. The goal is to achieve a culture of continuous improvement. That is, a workplace that is always looking for ways to do things better, and one where teams can solve problems on their own with limited intervention from higher-ups. Ron Barca works at Boeing Portland. he is part of the team that teaches the fundamentals of BPS. He explains the goals of BPS like this.
We're trying to make it where the work cell does not require a manager to point out what the team members need to be doing to be successful. We're working towards the idea that the work cell has clear goals and objectives, has the resources to do the work necessary, and when they find themselves not capable of meeting those goals and objectives, they can use systematic problem solving to resolve the problems that are within their own sphere of influence.
Javier's CARSEM group is working with Boeing to monitor this change and to try to understand the ways individual teams experience and progress through the culture change, as well as to identify what, if any, challenges exist in the process.
And we measure it from two different dimensions. The thinking, what is it that people think about what they're supposed to do, and how they're actually doing what they are being asked. What is the idealized version of what they have to do? So by measuring that gap, we can then identify areas of opportunity to adjust their training methods.
Traditionally, researchers who study continuous improvement models are interested in discovering best practices for doing a particular kind of work, and then replicating those practices elsewhere. But the CARSEM group is taking a different approach. They're not just interested whether or not something works. They want to understand why it works. If they can develop measurable, repeatable, provable theories about how organization change works, they can then apply those theories to other organizations. Sage Kittleman, who you heard from earlier, is focused on the role communication plays in this culture change.
And what I'm looking at is how communication can impact that culture to make that change happen more efficiently and effectively with limited turbulence. Well, the great thing about having industry like Boeing is they allow us to do interviews, they allow us to do job shadowing, and we can be on the shop floor and watch how communication patterns are going on in between the different team members, the different teams. How does all the information that's critical get up the ladder, and how does it come back down the ladder? Because usually as information, you get a lot of information at the team level of maybe critical stuff, maybe just day-to-day things that are going on, and that'll get trickled out as it goes up the ladder till the most critical information is taken to the top. But when you go back down, when you send all that information back down, is the amount of information that's left out, is that critical in the message coming back down?
Sage was brought into the Boeing project in 2015. Initially, her role was just to observe and see how the team members and leaders were interacting. As the CARSEM team conducted more and more interviews, she started to understand how the communication patterns were developing. And she was able to construct a theoretical model that shows communication within an organization is more than just a process.
You're looking at communication as a system in itself. And what that looks like is it has components and they all interact and they create this emerging system of communication. But on the inside, if you dig into it, you have the conveyance of information, the convergence of information. You have the conveyance of information that can be an independent system. It happens no matter what, as long as you convey something.
For example, as I'm talking to you right now, I'm conveying information. As long as your earbuds didn't fall out or your computer battery didn't die, I can assume that you heard me.
But on the other side, the convergent system is the individual understanding of the message, and that is a dependent system.
If you understood that, that's convergence. The receiver hears the message, but whether or not they understand it depends on a number of factors.
It depends on the type of information that's coming to them. It's the different channels of information that are being utilized. It's optical, it's auditory, it's all these five senses that you have. Communication is so broad, but when you look at it, the system in itself is how conveyance and convergence interplay is critical to the actual message and the effectiveness of communication.
Sage's model also takes into account that a person's understanding is hindered or aided by their worldview, the environment they're working in, and the degree of recognition between the sender and receiver of the information.
So as we were saying, for instance, in Boeing, while they have the production system, they have support systems and managers and so on and so forth, all working together. So communication is another system embedded into it that interacts with everything else. So it has to be thought of that way. Feedback has been removing her model because you can think of the sender of the information and as a sender and as a receiver at the same time, because as you're sending or conveying a message, you can also gauge how the message is being conversed or understood by the receiver. And that receiver at the same time is also sending signals or communication that hopefully indicates how the message is being received. So when I see you, or I can see from your face whether you're understanding or not, and when that is understood, then it changes the way you design a communication system.
Through job shadowing and interviewing at the Boeing facility, Sage has been able to test her model.
Being able to actually verify it through that involvement with Boeing has been hugely invaluable to my research specifically. Because it's one of those things that you really have to be in the field to be able to validate something like that. Like, okay, communication works, great. That's kind of those common sense things. But if you can see it in a production industry working and those different factors that are actually influencing it, then, that just adds so much more value.
It may seem like common sense. Communication is fundamental to how people interact. Is this really engineering?
I get the question all the time, this is really engineering? You're looking at communication. I said, well, what are organizations? They're social technical systems. You have the social side, which is humanity, and how humans interact with each other, but also how they interact with the technology and how you communicate with that technology. So yes, it is engineering. It's an engineering of processes. If you look at it like a black box and you have inputs and then you have something happen and then you have outputs, that's how communication works as well, depending on the characteristic of the input.
And you can measure that.
Yes.
That's why it's also engineering.
Yes.
We can assign metrics. Everything can be modeled numerically or mathematically. And that's part of her job.
Moving forward to the dissertation.
Siki Wang is another PhD student in Javier's lab. Similarly to how Sage is focused on communications as a system, Siki is focused on how teams function as a system. In Siki's model, a team can be viewed as a system consisting of people, the relationships they have with each other, and the resources shared between them. Each person on the team has different responsibilities, but everyone is working together to make something that is greater than what each individual can do alone. She walked me through an example of what a team system looks like.
If you're building a software, right, you need graphic design, interface people, marketing, programmer, and so on. But if you're only getting a bunch of these people together and assign, so you program this, you do the graphic, and you market the product. If you don't have the relationship, you don't understand what each other is doing, or like there's no expectations being communicated, then the product might just be a weird monster that doesn't compile, or the code doesn't run with the graphic, and the functions of the software is in the weird spot that is not intuitive for people to use, and the marketing strategy is completely wrong in terms of purpose software, right? So, but if you have a team that they know what they're doing, they meet, they communicate, and they have certain expectations of what each other is doing, there will be a more overall, more usable and a good product in terms of just having a bunch of people coming over and do whatever they're doing.
For the Boeing project, she's focused on how to track the progress of teams as they move through the 4 levels of BPS. In a nutshell, a Stage 1 team is one that can do its assigned work according to standards laid out for them by management. A Stage 2 team is able to use those standards to solve problems when they occur. A Stage 3 team can not only use those standards, but they can improve upon them. And Stage 4?
And then the highest stage, which is Stage 4, is a team by itself. So the team will be taking initiatives in problem solving, they know what they're doing, and they know when they can work on this problem alone or when they need help and where to get help.
But if you want to truly understand an entire culture, simply tracking a team through the stages is not enough. Once you can track a team's progress up or down, the next thing to figure out is exactly how the team got there.
in terms of team maturity, we really want to know what and how a team transforms from stage 1 to stage 4. Different teams are able to achieve that, but they might be going through different routes. Some takes longer, some takes shorter. Because based on our interview, we have teams completing from stage 1 to stage 3 in just a couple of months. Some takes more than years. So what difference makes those teams to reach that point differently? So the next step will be trying to, based on the interview we have with Boeing, learning what makes a difference between why some teams are moving faster and some of them are not.
So it's now been 3 years since the project began, and there's still a great deal to be learned. Javier is hopeful that what the group is finding out will be applicable across other organizations. For Ron Barca at Boeing, a lot of what this project has brought is validation that would not be possible without the help of outsiders.
This gave us capacity to do this kind of work that we would not have had otherwise. This type of project with the academic slant to it is just something that was unprecedented for me at this particular facility over the 3+ decades that I've worked here. Having students that already understood terminology and allowed them to come in and be comfortable in a manufacturing setting without necessarily understanding the specifics of the manufacturing allowed us to fairly rapidly execute this project.
At the end of the day, to achieve what Ron just said, it requires a lot of many different details to be accounted for, right? So our involvement, as Ron specified right now, has been to help them identify those gaps. Well, identify what's going well, where are gaps, what can be done better, and then they implement or take those recommendations. But also on the theoretical side, having the advantage of having this contact and learning from them has enabled us to develop fundamental theory that will be not only useful for Boeing, but also for pretty much anybody that wants to implement a cultural change and have a culture that will be about continuous process improvement. That's fantastic, and that is something that is extremely valuable. I believe that the willingness of Boeing Portland to do this. It takes a little more patience, but that's where there's the most value, both for industry and for researchers, right? Faculty and students.
Thanks for listening. This episode was produced and hosted by me, Owen Perry. Audio editing was by Brian Blythe. Our intro music is The Ether Bunny by Eyes Closed Audio. You can find them on SoundCloud, and we use their song with permissions of a Creative Commons Attribution license. Other music and sound effects in this episode were also used with appropriate licenses, and you can find those links on our website. For more episodes, visit our website, engineeringoutloud.oregonstate.edu. Also, please subscribe by searching Engineering Out Loud on your favorite podcast app.
The next most challenging part of the project, I'd say, is trying to convey what we're doing. And because we've gotten all this knowledge, but when you're trying to communicate it back to people, it's like, okay, how do you do that in a way that everybody can understand it and apply it? And that's a real challenge, it seems like.
You get on a podcast and you explain it.